tapping from a disconnect serving a computer room alternating current unit to feed a condenser on the roof is not an acceptable practice. The 10-foot tap rule applies to branch circuits serving a single-family dwelling unit. It allows for a tap conductor to be used for connecting a load that is not part of the original branch circuit, provided the tap is within 10 feet of the branch circuit's origin. The feeder serving a computer room alternating current unit is a critical circuit that must be dedicated to supplying power to the alternating current unit. Tapping off this feeder to feed a condenser on the roof would violate the following code requirements. National Fire Protection Association 70, also known as NEC Article 450.24, states that overcurrent protection for air conditioning and refrigerating equipment shall not be less than the larger of the branch circuit rating or the rating of the equipment. NEC Article 440.13 states that branch circuits shall be installed in accordance with the requirements of the Article 440 and shall have an ampacity not less than the maximum load to be served. The condenser on the roof requires its own dedicated feeder that is sized appropriately for the condenser's load. By tapping off the computer room alternating current unit feeder, you would not be providing the condenser with the proper overcurrent protection and ampacity. The proper way to power the condenser is to install a new branch circuit from the electrical panel to the roof. This circuit should be sized and protected according to the manufacturer's specifications for the condenser. When installing a new branch circuit, firstly determine the condenser's voltage and amperage requirements. This information is typically found on the unit's nameplate. Secondly, select the appropriate conductor size based on the ampacity requirements and the type of wiring method used. Refer to NEC Table 310.15b16 for ampacity ratings of insulated conductors. Thirdly, choose the correct overcurrent protection device such as a circuit breaker or fuse. The overcurrent protection device should be sized to protect the conductor and the condenser. Refer to NEC Article 240 for overcurrent protection requirements. Fourthly, install the branch circuit wiring from the electrical panel to the condenser location on the roof, ensuring that all wiring is installed in accordance with NEC requirements. This includes using the proper wiring methods such as conduit or cable, and providing adequate support and protection for the wiring. Fifthly, connect the branch circuit wiring to the condenser, following the manufacturer's instructions and NEC requirements. This includes properly terminating the conductors and providing a grounding connection. Sixthly, test the branch circuit to ensure that it is functioning properly. Use a multimeter to verify the voltage and current at the condenser and ensure that the overcurrent protection device is providing adequate protection. By following these steps, you can install a new branch circuit to power the condenser safely and in compliance with NEC requirements. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical work. The NEC provides comprehensive guidelines for electrical installations covering various aspects such as wiring methods, overcurrent protection, grounding, and equipment installation. It is essential to adhere to these guidelines to ensure the safety of people and property. Article 100 defines terms used throughout the code. Article 110 covers requirements for electrical installations. Chapter 2 covers wiring and protection, including branch circuits and feeders. Chapter 3 covers wiring methods and materials. Chapter 4 covers equipment for general use, including appliances and air conditioning equipment. Chapter 5 covers special occupancies, including data processing areas. Chapter 6 covers special equipment, including electric signs and outline lighting. Chapter 7 covers special conditions, including emergency systems. Chapter 8 covers communications systems. Chapter 9 contains tables and examples. Annexes provide additional information and guidance. Proper grounding and bonding are crucial for electrical safety. Grounding provides a low impedance path for fault current to return to the source, helping to trip the overcurrent protection device and prevent electrical shock. Bonding connects non-current carrying metal parts of electrical equipment to create a common ground path. The NEC provides detailed requirements for grounding and bonding in Article 250. These requirements cover various aspects such as grounding electrode systems, equipment grounding conductors, and bonding jumpers. A grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes. The grounding electrode must be connected to the building's grounding system using a grounding electrode conductor. Equipment grounding conductors provide a path for fault current to return to the source from non-current carrying metal parts of electrical equipment. These conductors must be sized appropriately for the circuit and installed in accordance with NEC requirements. Bonding jumpers connect non-current carrying metal parts of electrical equipment, such as metal enclosures and raceways, to create a common ground path. These jumpers must be sized and installed in accordance with NEC requirements. Regular inspections and maintenance are essential for ensuring the safety and reliability of electrical systems. Inspections should be performed by qualified personnel who are familiar with the NEC and local electrical codes. Maintenance should include regular cleaning, tightening of connections, and testing of overcurrent protection devices. During inspections, look for any signs of damage, such as cracked insulation, loose connections, or corroded terminals. Also, check for any violations of the NEC, such as improper wiring methods or undersized conductors. Overcurrent protection devices should be tested regularly to ensure that they are functioning properly. Circuit breakers should be tested using a circuit breaker tester, and fuses should be inspected for signs of damage or overheating. Any damaged or defective equipment should be replaced immediately. Electrical safety training is essential for all personnel who work on or near electrical equipment. Training should cover topics such as electrical hazards, safe work practices, and the proper use of personal protective equipment. Employees should be trained to recognize and avoid electrical hazards such as exposed conductors, energized equipment, and overloaded circuits. They should also be trained to use safe work practices such as lockout/tagout procedures and the use of insulated tools. Personal protective equipment such as rubber gloves, safety glasses, and insulated clothing should be used whenever working on or near electrical equipment. Employees should be trained on the proper use and maintenance of this equipment. Lockout/tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. These procedures involve disconnecting the equipment from its power source and applying a lock and tag to the disconnect switch. The lock and tag prevent anyone from accidentally turning on the equipment while it is being worked on. Only qualified personnel should perform lockout/tagout procedures. The NEC provides specific requirements for lockout/tagout procedures in Article 120. These requirements cover various aspects such as the identification of energy sources, the disconnection of equipment, and the application of locks and tags. Understanding and adhering to electrical codes and standards is essential for ensuring the safety of electrical installations. The NEC is the most widely used electrical code in the United States, and it provides comprehensive guidelines for electrical installations. Local electrical codes may also apply, and it is important to be familiar with these codes as well. In addition to the NEC, there are other electrical standards that provide guidance on specific aspects of electrical installations. These standards are developed by organizations such as the Institute of Electrical and Electronics Engineers and the National Electrical Manufacturers Association. Staying up to date on the latest electrical codes and standards is essential for electrical professionals. This can be done by attending training courses, reading industry publications, and participating in professional organizations. Always consult with a qualified electrician when performing electrical work. They have the knowledge and experience to ensure that the work is done safely and in compliance with all applicable codes and standards.